Hi guys, how's it going? So today actually we're gonna go through a system design concept. We're gonna be designing an API rate limiter. So you can think of an API rate limiter as a service that throttles user based on the number of requests they are sending. So let's say for instance we have a server here, right? And there's a user who is actually sending probably like 100 requests per minute. So if we allow such behavior, it's going to take our server down because our server will be overwhelmed by the number of requests. So now to overcome this, we can say, okay, we can only allow 10 requests per minute. If a user send maybe 11, then we're going to reject that. So it's not even gonna get to our server. So in a nutshell, that's what an API rate limiter does, and most of the applications they have this in place. Now let's look at the functional and non-functional requirements for building such a system. So we can assume that within a time frame we want to limit the number of requests a user can make, right? So another point is that because we are working in a distributed environment whereby our servers are horizontally scaled, we can assume that the API should be accessible across the servers. Okay. If the user makes a request and we throttle them, there should be an error message to let them know that they have reached a limit of the request that they can make, right? In terms of the non-functional requirement, we can say that the system should not introduce any latency. So we want to have low latency. And secondly, the system should be highly available. So we can't afford the system being down because any chance that the bad actor get can actually bring down our server. So we want it to be highly available. Before we get into like the detailed and the meaty of the system design, I just want to talk about the type of throttling that we can have. This is mainly because not all the time we want to immediately limit the user request based on throttling limit. So I think there's some application or some scenarios at some point whereby you want to say that, okay, the user, yes, they did maybe exceed the throttling limit, but we don't want to reject them. Given that we have enough resources, something like that, we can still allow them. And this is mainly because maybe the application, you want to be productive on the application, you want something to be done, right? So hence I'm saying that not all the time we go into want to have a hard throttling. So this is also known as a hard throttling, whereby we say that if a user reaches a throttling limit, we reject their call, right? But we can also have a soft throttling, right? Which is that if the user, we say that, okay, a user can make probably like 100 calls in a minute, but if they exceed this, we can still allow 10%, more. So which means that they can maybe make another extra 10 calls, right? Another type is the dynamic throttling. So this is saying that if we have resources, and the user have exceeded the number of requests that they can make, because of we have resources, right? We allow the user to make the request. It's okay. because now our server won't be overwhelmed because of we have resources, right? What are the type of algorithms used for rate limiting? The first one is called fixed window algorithm. So you can think of this as we have a predefined start time and end time within our window frame. So let's say, for instance, let's say we have a rate limiter of 2 messages, right? Maybe a second or so, right? And then if we, in a second, we allow 2 messages, like, a user can make a request 1 and 2, that's okay, right? They made it 2 messages within the second. Then in the next second, they make 3 messages. So what will happen is that that messages will be throttled, right? So because we only take 2 messages. But the point here, the term fixed, it simply means that we have a start and end predefined time. So if it's 1 second, like we know that at each start of the second, it's a start at each end of the second, something like that, right? That's why we have this fixed concept there. Okay, so the second one that we look into is called the rolling window. So it's called the rolling window algorithm. So in this case, what you can think of is that the time is configured from the function of the request is made plus the window length. What I'm saying here is that, let's say you make a request. Let's say we said that, okay, we have a request. Instead of like considering it like within a minute, let's say a minute, 0 to 60 seconds, instead of considering like this, right? We say that we only consider from the time you make the request. So if you made the request at 15 seconds or so, right, we're going to add plus 60 seconds because we set a minute. So we're gonna add 60 seconds. From 15 seconds we add, and then this length here, it's 1 minute. It's one minute, right? So that's how it works. So we don't say at each start of a minute, or we then at each end of the minute. That's like our window. No, we don't do it this way like a fixed window. Rather we are flexible. We say whenever you make the request, like let's say you started at 15 seconds, we just like add plus 60 seconds to say, okay, this is what we're gonna consider. Okay. So for instance, let's say we have 0 second, and we have maybe 1 second, we have 2 second. Let's say we said that we allow 2 messages a second, right? So let's say you make a message here, the first message, you make another message here. The window for this, it's gonna be here. So this is 1 minute, 1 second, sorry, it's 1 second, starting here to here. So you can think of this as like a half a second, and also another half a second, which is gonna be 1 second. Then you make a request, another request here. This will be throttled. It will be throttled. So that's what it means essentially. Let's look into the high-level design of the system, right? So we can think like we have a client, okay, and we're gonna have a web server, and we're going to have the rate limiter, saviors, which is going to have a cache and database. Then we're going to have our API server, okay. These are all the servers that we have. So the client make a request, then we check if they have not been throttled, they have not reached the limit. If they have not, we then send their request to our API server. So in terms of capacity estimation, so we can assume that in the storage we're going to store the user ID, right, which you can going to take on average, let's say take 8 bytes. We're going to have a count, which is going to take 2 bytes. We're going to have the time, which is also going to take 2 bytes if we store minutes. Then we're going to have a total of 12 bytes, right? So assuming we have 1 million users, so we can take the 12 byte and multiply by 1 million users. We're gonna get 12 megabyte. Okay. So yeah, we will expand on the eviction policies at the end. For now, I just want to estimate the amount of data that need to be stored. So now I want us to look at an example of like a use case whereby like a user make a request and they get rejected. So let's try to do that. So let's say that we want to limit the number of requests per user. So what we'll do is that we're gonna say for each user we keep a count. For each user we keep a count representing the number of requests that the user has made, including their timestamp. For instance, we're going to store this in a key value pair format. So we have a key value. So we say, okay, we store the user ID, and we store count, and we store timestamp. Given that now we have a table structure like a hash table, so I want us to make an example whereby the user will be throttled. So for instance, let's say that our rate limiter can take 3 requests per minute, right? So the first instance will be, okay, the user has never made a request to our site. So it will be that we don't have the user ID. So if the user ID is not in table, so what we want to do is that we want to insert that user. So we're going to insert the ID, like the user ID 453, right? Then we're going to increment the account plus equals to 1. Then we want to set the start time, because they just made a request now. So the start time will be their current time, or the current time they made a request. Okay, so that's what it means. The second scenario will be if, right, the user has made a request. So the user ID is in table. The question will be now, what we want to check is that we want to say, we want to take their current time and we subtract by the start time when they made a request. And if this is greater than equals to 1, then we want to set their start time to the current time. I don't know if this makes sense, so let me explain it. Then we're gonna count 1. So let's say this is 1 minute, right? This is 1 minute. This is another 1 minute. So it's 2 minutes. Just like that, right? So the point that I'm raising here is that they have a start time, they have an end time. So let's say their current time, now it's here. This is their current time. So I am saying that if it happens that we take their start time, and we take the current time, and we subtract it by the start time, if this is greater than 1 minute, it's greater than this, then we know that definitely we should create another window for them. We're gonna create another window for them. Yes, it makes sense because of this window here is expired. This window is expired. They have went to another window. So we create another window for them. Hence here I'm saying their start time now, their new start time will be their current time. Then I count +1. Okay, hope it makes sense. Just let me know if you didn't understand, but maybe as we continue you will understand as we're gonna get into this. Then after this we allow the request, right? Another situation will be like if now their current time, right, minus start time, it's actually less than or equals to 1 minute. So which means that now they're within this window. So they're within this window. So what we want to do is that we want to check the number of requests that they have made in this window, because we said we'd only take 3 in the window. So what we'll do is that we'll ask if their count is less than 3. If it is, then we just say allow request, right? If it's greater than 3, if their count is greater than 3, then we're gonna say else, then reject request. We're rejecting request because we said within a window we can only take 3 requests. So they probably have something like 4, so we don't want that. So that's how it will work in a nutshell, right? However, fixed window algorithm has certain limitations that we should discuss, right? So what happened is that because we know that at each end time, at each end of the minute, we have to restart the window frame, right? So for instance, we said that we have a 3 minutes request that we allow, and this is 0 to a minute. Then at the next minute we start 0, a minute, just like that, right? So at the end of each minute we start again 0, 1 minute, then we take, here we can only take 3 requests. So the point is that the limitation about fixed window is that if a user, we said we take 3 requests, if the user makes a 1, 2, 3, right? They make it 3 requests. This is allowed. This is perfect. It's fine. Then in the next window, like you can imagine that here, maybe it's like, 59 seconds. It's like 59 seconds. Then in the second minute, maybe here it's like 2 seconds or so. In the next window, 2 seconds, they make another 3 requests, right? So you can tell that in a span of less than 5 seconds, they were able to make how many requests? 6. And we allowed them because yes, it makes sense because if it's a new window. So this is the downside of the fixed window algorithm. Because of it's fixed, so users can make more requests within a short time of period if those requests are close to one another, like this. So, right? Another Another disadvantage of the fixed window algorithm is the atomicity. Right. Atomicity. So what I'm saying here is that in a distributed environment, right, the write and read behavior can create a race condition, right? So what I mean by this is that, let's say we have a count for the specific user which is equals to 2. So, and the user make another request, right? Maybe the user make another one request, or maybe a user make 2 requests. So let's make this make 2. The user make 2 requests, and the current state in the hash table is 2. Because we are in the distributed environment, let's assume that two processes handle one process handle another request, one process handle another request, right? So these requests, these processes, they're gonna think, okay, they're both gonna see 2, another one is gonna see 2, so they're gonna think, okay, this is fine, we can allow. So this is gonna allow, and this process is gonna allow, then the other one is gonna allow. So you see, the user has made 4 requests, right? They had 2. This process, because they read from this, and then on this state, they read from this state of 2, then they end up with 4 requests. So there are certain ways in which we can work around this. One way is that we can if we're using a hash database like Redis, you can use Redis lock. So it can overcome the atomicity problem. However, it can also slow down concurrent request. And the Redis lock is provided on the enterprise version, right? So which means that if you don't want the enterprise version, then you're going to need to build it from scratch, right? So that's a downside of this. Given the downside of the sliding window algorithm, of the fixed algorithm, so I thought let's look at the sliding window algorithm. So how will this work, assuming that we have 3 requests per minute, right? So how will this work is that we can assume that, okay, if we get a user ID that is not in our DB, not in DB, we're going to insert the user ID, right? After we insert the user ID, we set their start time to, it's going to be, their start time is going to be their current time, right? Unlike with the fixed algorithm whereby the start time is determined by the start of the minute, all right? So this time, their start time is determined by their current request, right? Like their current request within the start of the window. That's what I'm saying. Then we're just going to increment the account by 1. Then we allow the request. Okay. If what could happen is that their current time it's actually greater than the start time plus 1 minute. So we said that we allow 3 requests within a minute. So we say, okay, the time they started their request, start plus 1 minute, right? So we need to create a window for them. Remember that it's something similar like this. So what I'm saying, that their start time was here, right? Then we added 1 minute to this, 1 minute. So they make another request, a new request, they make it here. So we know that, okay, if they made it here, this current request is greater than this previous time. So this means that we need to create a new window for them. Okay, so what will this mean is that we're gonna say their start time is gonna be equals to the current time, right? Start time is gonna be their current time. Then we're gonna say count plus equals to 1. Then we're gonna allow them the request. Okay, else what will happen is that we can say the user current time is actually less than the start time, so which means that they are within, this is the start time and the current time, it's within this. So we just have to say, and this current time it's not greater than the start plus 1 minute. So we just want to make sure that they are within a window. So the reason now we're focusing on this part is because we want to count the number of requests that they've made. So we're just gonna say if their count is actually less than or equals to 3, we're gonna allow the request, else we're just gonna reject the request. That means the count is greater than 3, so they have exceeded the limit that we have. Okay, so what will the space be in terms of like capacity estimation? So we can assume that, okay, we have a key value, right? And in this key value, we said that we store the user ID, right? And we said that we're gonna store the count and the time stamp. So the state that we want, honestly, it's that we wanna keep track of the start. We don't want the end because we can always add plus a minute to that. So we wanna keep the start time. The current time will be coming from the request in a form of a parameter, right? So what do we want to say? That we know that we said that, okay, for each record it takes us 12, not for each record, rather for all the users, like 1 million users that we have, it's going to take us 1 megabyte of record. This is assuming that what we do, we don't add inside this hash, rather we replace. For instance, we update the count here. Let's say that it was 1, we change this to be 2, we change this to be 3, we change the start time based on the current, just like that, based on this algorithm that we spoke about, right? So that could work. However, the question is that what if now they introduce that, okay, we want to have an hourly or a daily limiter, right? So this storing the data like this won't help us, right? So because of we said that, okay, we will persist everything, right? We will persist every request. That means that we will need to, if we have a daily limiter, we will need to go to the database, which is an expensive, because reading directly from the database can introduce latencies. So we're gonna have to read from here the first request that they made in a day and the last request that they made in maybe the last request that they made, and we have to do this, like, right, because in reading from database, like I said, it introduces latencies, so it can be expensive. So then, because of this, how can we then design this better? So how we can do it is that we can say in this value, we are going to add every request, every count that they make. So we're going to keep track of everything. But we're going to use a linked hash map. So you can think of this as a data structure that actually maintains the order of the elements in which they were inserted, right? So the reason I'm using this algorithm is because when we read from the hash map, we want the latest timestamp. We want to know their previous request and their previous count. All the time we want to know the previous time, so that we want to know that. So linked hash map is going to allow us to go straight to the user, and we go inside here. We are able to insert efficiently. We are able to retrieve the element efficiently. So because we will be incrementing each request inside the value. Okay, so now given that, let's assume that a day each user make maybe 100 requests a day, right? So given that we have 12 megabytes, we're gonna multiply this by 100, which is gonna give us 1.2 gigabyte that we need to store, right? So that's how essentially it works. So yeah, given that for every request will need to be stored, like right into our hash table. So let's discuss sharding. So by sharding, I mean how are we going to distribute this large data set across multiple servers in order we can improve performance and scalability. So we one way we can do is that we can shard by the user ID, right? So however, I want to say that if we have multiple API services, right, it will be good for us to shard by user ID and the API, right? We can also consider using consistent hashing for fault tolerant, right? For fault tolerant and for replication. Okay. When it comes to our caching invalidation, so we will be using the write back cache. This is mainly because we don't want to introduce the latencies as we write to the database. So we can think like we're gonna write to the database at like intervals, right? So we store all the data in a cache, then we're gonna persist it into the database at intervals, right? So now we don't want to introduce the latencies. That was the main requirement. So if we have a request, we store everything into, and we get everything from the cache, right? So there are certain techniques like write through, write around, but they require like us writing frequently, interacting with the database. So we just trying to avoid that, right? So we just want low latency as possible, right? So the last component that we should consider is that should we rate limit the user based on IP or user ID, right? So with the IP, web scrapers can rotate IP addresses, right? So they can rotate them. Another thing is that if people are working in the internet cafe, they share the same IP address. Okay, so that could be a problem. So if we use the user only, then this only applies to the logged in user or the registered user. Only applies to the registered, or because if now, like, that means that if like we have an e-commerce, right, like website, something like that, like Amazon, Twitter, even unregistered user can come and see the product, right? They can still make a request to the server. So this user ID might apply or might not apply to them because they are not registered, right? So one way probably one can say, okay, let's combine the user ID and the IP address for the logged in users. So, however, this brings us back to where we were, which is that yes, it could help to detect accounts which are created by the same person, and like, because we know that, okay, there are certain accounts which are using the same IP address. So maybe these accounts are owned by one person. This person could have to make an account to make multiple requests. Maybe this could be for web scraping purposes. However, the reason I was saying that it brings us to back square one is because there could be people who are using multiple. There could be a scenario whereby we're getting multiple accounts with the same IP address, and this is where it's in the internet cafe. It's like multiple people are logged in using their account, but then they're sharing the IP address. So that's like that's one thing. So yeah, I think that's that, guys. That's the system design. I hope you enjoy this content. If you enjoyed it, hit a like, subscribe. This motivates me to keep on giving you guys this content. So thanks, bye.